video, we are going to see the problem on isometric projections, and for that, here we have a question. It is given that figure below shows two views of an object. Draw its isometric view. So here if we see, the front view of the object is given and the top view is given. Now with the help of these 2D drawings, two-dimensional front view and top view, we have to form a three-dimensional object, that is the isometric view. And just as we start the question, at first we should know how much is the total length, height and width of the object. Now total length is visible both in front view as well as in top view. Now when I see the top view, here I have 35 mm, then this is 15 mm. Again if we see in the front view, this is the length is 35 mm up to the center. So it means 35 plus 35, that is 70, plus 15. So 85 mm from origin or point O to the center, the distance is given, which is 85. Now after this center up to the extreme end, we have the radius as 35. So after 85 mm, we have to add 35, and that will give me the value as 120 mm, which is the total length. Next, for the total height, we have to look into the front view, because in the top view height is not visible. So here the height is, we can say that it is corresponding to the diameter of semicircle, which is 70 mm, and the total width is visible in the top view, that is 20 plus 30 plus 20, that is again 70 mm. Now once the total length, height and width of the object is known, we can start with the problem. Drawing a light horizontal line. Next, selecting a point over here, and in case of isometric projections, object is inclined at 30 degree on both sides. So measuring 30 on one side, 30 on other side, drawing light line through these angles. Then drawing a light vertical line. After that, here I'll explain where we have to mark the length, height and width. For that, I can say that we have to look for the origin, and origin for the object is here. In the question also origin is given, it is at this location. Now when I see this top view, the origin is at this location, means I have to remove this object, and the same origin will be there in the front view as well at this location. So when I remove this front view and keep it here, length will be along this side. If the origin would have been here, then the length would have gone on this side. So here I have to mark the length, which is 120 mm. Height is 70 mm. It will be marked here. Width is also 70. Then through these points, I will be drawing light vertical lines. Here the height I have taken 70 mm. I'll mark it on this side as well. Even here, joining them. Drawing a parallel line. Over this, I'll mark the length 120. So this is the rectangular block inside which I would be drawing the complete diagram. And in order to simplify this drawing, here if I look into the front view, this is 35, and from the center up till end, that is also 35. So leaving 70 mm from one side, I can divide this drawing into two parts. First is this semicircular portion, which will be of 70 mm length, and then the remaining portion. So here I am taking a length of 70 mm from this side. Then joining these two points. Next, I'll draw or take 70 mm from one side as well on this length. Now I have divided this drawing, semicircular portion and this block. So for the semicircular portion, it is having a width of only 20, not the complete width 70. So for that, I'll mark the center of the width. That gives me the center. After this, from the center, since the width is 20, I'll mark 10 mm on both the sides. 10 mm on one side, 10 mm on the other side. Then drawing parallel lines along the length. Next, through this point, I'll drop a perpendicular, measuring the total height 70 from here. Drawing parallel line. Now, here I am getting the parallelogram inside which I would be drawing the semicircle first, and then I would be moving on to the next block, which would be here. So it is better to start with the semicircle. Semicircle is having radius 35, so diameter is 70. I'll explain the procedure how to draw that semicircle. For that, here we need to have the side as 70 mm, that is completing the parallelogram, marking 70 mm over it. So here I am getting a parallelogram inside which I would be drawing the semicircle part. So here, to draw the semicircle, inside this parallelogram I would be drawing a longer diagonal like this. Then the sides are of 70 mm. I'll mark their midpoints. Then joining the top midpoint to its opposite bottom corner like this, so that it cuts the longer diagonal. Next, bottom midpoint to the top corner, opposite corner, cutting the longer diagonal. Then I just want a semicircle, so it should end between these two midpoints. Through them I am drawing a light line. Within this line the semicircle should end. Now where this longer diagonal has been cut with the help of this line, here I am getting a center. So keeping this center, and here is the radius. I'll draw a light arc keeping this center, and this much is the radius, getting another semicircle. Now this semicircle is having a width of 20, so behind this there will be another semicircle. For that I'm projecting the points, that is where this arc is cutting the longer diagonal. This point I'm projecting it back. Next, this midpoint and the center which I had used. Now since I have to go 20 mm behind, I'll mark 20 mm over this line, that is the center is shifted. Next, keeping the same radius which I had used, but center is being shifted. Here I'll draw an arc. Then both these semicircular parts should be joined. After that, once I have drawn the semicircle, next inside this semicircle there is another circle of 40 mm diameter. For that, the first thing should be, we need to get the center of this parallelogram, because center of both circle and semicircle are same. Getting the center here. Now since the diameter is 40 mm, I'll mark 20-20 on both sides. Next 20-20 on the other side as well. Then from these points I need to draw parallel lines to complete the parallelogram. Then vertical lines. So here is the parallelogram inside which the circle should be drawn. Now the longer diagonal is same for both the parallelograms, and here I have the midpoint. So again, top midpoint to bottom corner intersecting the longer diagonal, bottom midpoint to top corner intersecting the longer diagonal. Where it is cutting, here I'll get two center points at this location and here. Then keeping this center, radius is up till here. Drawing a light arc, then keeping this center, that is the corner of the parallelogram, and this much radius, joining these two midpoints. Next, keeping this center, this much radius, drawing an arc. Next, keeping this opposite center, and here is the radius, joining these two midpoints. Now this is the circle which should be there inside the semicircle. I am keeping it light first. Then inside this I have to see if we can get another curve. For that, the same center which I had used, which is this one, I'll project it back by the same width, 20 mm, taking 20 mm width. Then the radius is same, keeping this center, I would be drawing a light arc. Now this much part is visible. Then once I have completed the semicircular portion, I'll start from the other side. That is, I would be drawing these surfaces. Now when we look at this surface, here it is having 45-degree inclination. Angles in case of isometric drawing should not be measured directly onto the diagram, because the diagram is already inclined at 30 degree. It is not a horizontal line. So we need to measure this angle separately and bring it over here. For that, here I'll draw a rough diagram of the same figure, which is leaving this 70 mm, whatever is left, that is 50 mm, is this block. So the length of the block is 50. I am drawing it somewhere here, or even at the top, it would be fine. Drawing a light line, marking the length of 50 mm over it, 10, 50 mm. Next, vertical lines through these points, vertical lines. This procedure we have to adopt if we have an angle in the drawing. Next, as can be seen here in the top view, after 15 mm, the remaining length is 35. It means it is 15 mm straight horizontal line. After that it is sloping, so that remaining length is 35. So measuring 15 mm from one side, which is the straight portion, projecting vertical line through this point. Now the height of the object is 70 mm. Next, after getting this 15 mm at the top, now from here I'll measure the angle of 45 degree. That is from this location, I'm taking the angle as 45 degree, and then drawing this line which is inclined. Now I get the height of this slope and making this surface dark. So here I am completing this surface. Now the inclination of this surface is given 45 degree. So from this I am getting this height where the slope would be cutting. First I am taking this distance, which is from the top, marking it over this side, because up to this the surface will be straight, and then measuring this height, marking it over here, and even on the other side. Now I would be joining these with the help of light lines in order to get the slope. Next, joining these 2 points. Now after this, again on this slope as well, there is another surface which is inclined at 60 degree, and again, as I have explained, whenever you have such angles inside the drawing of isometric, measure them separately and then bring it onto the diagram. So again, this surface also I would be drawing it separately, like it is having width of 70 mm and this distance is 35, which is the length. So here in this case as well, I am drawing a light vertical line, marking 70 mm over it, then horizontal line. The portion has a length of 35 mm. So this is 35 mm, drawing parallel vertical line. As I can see here, after 15 mm, this groove is starting, that is 15 mm length. So I'll take 15 mm from this side, drawing a light line. Then I'll take the center of this width, which is 70, so half of that, that is 35, drawing a light line. Next, in order to draw this surface, it is leaving 20 and 20 mm on both sides. So here I'll measure 20 mm from one side, 20 mm from other side, and then the angle is given as 60 degree, as can be seen here. So from this point as the reference, I am measuring 60 degree and then drawing light line through this so that it cuts this vertical line. Similarly 60 mm from here, this is 60 degree, joining the points in such a way that it cuts this vertical line. Now this is the surface, I'll make it dark. So this is the surface which is given in the diagram, having 60 degree angle on both the sides. Now once I get this surface, I can directly plot its points onto the diagram. Like since it is, this surface is there on the slope, starting from the slope, so I'm measuring the distance from this center point up to this inner point, and just before that I'll take the center of slope as well, drawing vertical line and projecting a line parallel to this plane, which is the sloping plane. So here, as I have measured the distance from the center up to this point, I am marking it on this side as well as here. After that, I'll draw light lines through them, connecting these 2 points because this surface will be visible. Next, to get these points here, first I require a length of 15 mm. That length is already there. I had drawn the diagram to the dimension, so that length I am marking over here. Now projecting that length onto the sloping surface, here I get the point on the slope, so projecting that point onto the slope parallel. Now this is the point which is the reference for us, and the same point is here. So I take this center point and the distance up till here and go on marking it on one side as well as on other side. With the help of light line, I would be joining them. Then from here I am going to drop a light vertical line. Next, parallel to this surface, I would be projecting a line here parallel to this surface. Now through it, horizontal line connecting them. So this will be the complete surface, and after this I'll start making it dark really quickly so that we can understand which portion is visible, which is not. So first I'll be making this block dark, then moving on to the semicircular and circular part. I'm making this slope dark. So now joining these 2 points, it will be connected only up till here, because when we are looking from top, this semicircular disc and the surface here, they are connected. There is no dark line in between them which indicates change of plane. So here there is no change of plane. so they would be connected dark. Then I'll be making this semicircular portion and the circle also dark, starting with this circle. Only up to here it is visible, not behind this surface. This arc is only visible up to this much. Length will be only visible up to here. Then this arc which was behind, joining all of them with the help of dark lines. So here is the complete diagram for the given figure. If we look into this diagram, from the front the semicircular portion and the circle are seen. Both are behind, as we see from the top view. They are behind this block, so it is going behind, having 20 mm width. Next, this sloping surface is seen. Yes, it is seen from the front view. From the top view, there is change of plane. This surface is exactly horizontal, whereas this is a sloping surface. So there is change of plane. That is why dark line in between them. From the top, semicircular portion is seen as a disc of 20 mm. Yes, it is seen as a rectangular disc. And once I have completed all the diagrams here, there is no need to give the dimensions. In case of isometric projections, we can leave the diagram as it is. And as I have explained, we don't have to measure angle directly onto the diagram. Measure them separately and then plot it onto the diagram. And with this, we complete the problem.